Hi everyone, welcome to Mathematically Inclined. Permutations and combinations. You wanted, you got it. I have never seen any competitive exam without this topic. So let's see how we make it more interesting and quick. Let the magic begin. So beginning with the distribution problems, whether you do them logically or with the formula, they are quicker than you think. Yes, you can solve them within 3 seconds. I have written 4 questions over here with a slight modification here or there. I would request you all to pause the video, take its screenshot, and then let's start cracking them. So looking at the very first one, it says find the number of ways in which 8 distinct toys can be distributed amongst 5 children. An answer to this one should be 5 raised to power 8. That's it. Moving to the second one, find the number of ways in which 10 different prizes can be distributed amongst 6 people so that every person receives at most 9 prizes. The answer to this one should be 6 raised to power 10 minus 6. That's it. Third one, it says find the number of ways of distribution of 8 identical balls in 3 distinct boxes so that none of the boxes is empty. And the answer to this one should be 7C2. That's it. And the last one, it says find the number of ways in which 30 apples can be distributed amongst 5 persons. So this one should be 34C4. Yes, it is this simple. Want to know the secret? Watch out this video till the end. So talking of the logic or the formula part, now I have divided this distribution problem further into if I have n things which have to be distributed amongst m people. How would we do that? First of all, you would have to check whether the things that I am talking of course, people would be distinct. So this depends on whether the things are distinct or the things are identical. If the things are distinct, then the first case arises where I am given no condition on the question. By this I mean that I can give all the things to the same person also. If I am not specifying any condition, then it's obvious everything can go to anyone. This will always give you the answer m raised to power n. You can also look at it this way, that you can say it's a fixed thing raised to power the variable thing. That means, look at the first question. It says find the number of ways in which 8 distinct toys can go to 5 children. Now they are specifying that the toys are distinct. So we have to fall under the first category. It can go to 5 children. So what's fixed over here is children. By fixed I mean you cannot move. When you have toys, you do not really pick up the child and say this is the toy. You pick up a toy and then look for probable children. So fixed raised to power variable, that means it is simply 5 raised to power 8. So logically or with the formula you can solve it in split second. Not all to one. That means there is a condition in the question which is telling you where it is specifying that not all the prizes or all the toys go to the same person. In that case, all you are going to do is fixed raised to power variable minus fixed. That means m raised to power n minus m. Look at the second question. It says find the number of ways in which 10 different prizes can be distributed among 6 people. So if the question was only up till this point, then you know 6 people. So here if you pick the first prize, you have 6 options. Again, you pick the second prize, there are 6 options. So 6 into 6 into 6, 10 times 6 raised to power 10, or by the first case, the answer should have been only 6 raised to power 10. However, there's a twist. It further says so that every person receives at most 9 prizes. This is another way of saying that a person can get maximum of 9 prizes, but not all the prizes go to the single person. So not all to one. Now there are 6 people, so I'm subtracting the possible ways in which a person can get all the prizes. So it is simply 6 raised to power 10 minus 6, or fixed raised to power variable minus fixed, or m raised to power n minus m. I hope you got the idea. Moving further, all to one means I have identical things, but then it can all go to the same box also, since there is no condition. By this I mean, look at the 4th question. It says, find the number of ways in which 30 apples. Now, given 30 apples, you cannot really make out which one is which. So they are more or less taken to be an identical object until specified. Can be distributed amongst 5 persons. In short, there is no condition. In such a case, the answer is always n plus m minus 1, c m minus 1. That means I add the fixed and the variable things, minus 1, c fixed minus 1. Just look at the question. So whenever you come across certain identical things which are to be distributed, just look for one thing. Is there a condition? Is there not a condition? If there is no condition, you simply apply this formula. So in this case, it will be 30 plus 5 minus 1, c 5 minus 1, where this is n, the identical things, plus the fixed number of things minus 1, c fixed minus 1. So the answer was 34C4. Likewise, in case there is a condition applied, by this the condition would be that no one goes empty-handed. Basically, everybody will get something or the other. In this case, your formula is simply n minus 1, c m minus 1. Needless to say, for such cases, your m is less than n. Look at the example, which is question 3. It says, find the number of ways of distribution of 8 identical balls in 3 distinct boxes. So if you read the question till here, ideally, if you read the question till here, the moment you see identical balls in 3 distinct boxes. So if the question was till this point, I would apply the previous formula, which would be 8 plus 3 minus 1. That makes it 10C2, and that would have been the answer. However, the question continues further, so I don't use this. It says so that none of the boxes is empty. In short, every box will have some ball. In this case, the formula is 8 minus 1 C, the fixed minus 1, which is 3 minus 1. So 7C2. That was the answer. Wasn't it easy and quick? Alright, let's look at the new set of questions and try to fit in our formulas. So the 5th one is a very common one. It says, in how many ways can 7 letters be posted in 4 letter boxes? Now, of course, if nothing is mentioned, 7 letters cannot be identical. So please note the identical word is essential here. Now, as you can see, so there are 7 distinct letters and there are 4 letter boxes. Needless to say, the letter boxes are fixed. You don't pick up a letter box and then choose the letter. Rather, we pick the letters. So the answer would be simply 4 raised to power 7. As simple as that. Moving on to the next one, it says, in how many ways can 3 prizes be given to 4 boys when no boy gets all the prizes? So first of all, it's important to note, until specified that the prizes are identical, we are going to take them to be distinct. Further, as you can see, there is a condition applied to this, so we have to stick to the second formula, and we say boys being fixed, it will be 4 cube minus 4. Moving on to the last one, which seems to be slightly tricky, but trust me, it is not. It says the total number of non-negative integral solutions of this equation. would be how many? Now you might feel it doesn't fit into any of these, but it does. If you picturize it as that we have to distribute 100 things amongst 4 people, because what's happening is that 4 of them are adding up to give us 100. So if I take 100 to be the things, now I know nothing is specified over here, but then since we are talking of solutions, you know we can get the same solution also. For instance, I can have all 4 of them to be 25. So that means there is no condition in the question. It simply says that I have to distribute 100 things amongst 4 people, where since there is no condition, so it is simply that all of them go to 1. In this question, that means all of them can have the same solution. So very conveniently is the first option, and the answer would be 103C3. Finger. I know you people always wait for do-it-yourself questions. So here they are. The first one says the number of non-negative integral solutions of x plus y plus z equal to 40 are. And the second one, in how many ways can 5 rings of different types be worn in 4 fingers? Well, you know the method, you know the logic. Make sure to comment in the section below and let's see who are the first 3 winners who get these absolutely right. So your time starts now. If you found this video useful, do let me know in the comment section below. Do not forget to like this video, share it amongst your friends and juniors, and hit that subscribe button. Also let me know if you would like to see more shortcuts and tricks in permutations and combinations. I will see you with the next exciting video real soon. Until then, bye-bye.